Hi everyone, my name is Zilberfeld. I'm the product manager at Typemock. Welcome to this webinar. This one's going to be about real-life unit testing tools and practices, which actually we're going to talk about mocking and best practices for dealing with legacy code and writing tests for everyone in attendance. If you want to have a chance of winning an Isolated ++, which we're probably going to see an example in later on, if you want to win a license for that, please tweet about this webinar with the hashtag unit testing or the Typemock username. So, without further ado, let's begin. So, these are the things we're going to talk about. We talk about why dealing with legacy code that we actually basically have 95% of the time, what kind of problems it presents for people who want to write unit tests. And we'll talk about how isolation helps. And I'm going to give a couple of examples of how to use Handrolled Mocks on a mocking framework. Talk a bit about other different mocking frameworks. And at the end, I'm going to keep for talking about best practices when writing unit tests in general. So this is a fact. People write millions of lines of legacy code every day. Question is, what is legacy code? And there's a good book by Michael Feathers called Working Effectively with Legacy Code, in which he defines legacy code as code that doesn't have any tests. This is a very interesting definition. Like for me, legacy code is something that you haven't looked at for 3 days. But Michael Feathers talks about, there's a reason behind this. If code doesn't have tests, then the code rots. Without tests, we're very afraid. We're scared to touch the code when we're entering bug fixes or new features into an existing code base. We're afraid to touch it because when we do, there might be some kind of a side effect, an unforeseen one, and it's scary. It's really scary. And if we don't touch the code, we don't have the courage to test, to change it, and that means also refactoring it. Without refactoring the code, we can't really do it easily. If the code was refactored and it was a beautiful code, it would be easier to make changes to it. But again, if we're talking about not having tests around it, then again, we're going to be not so brave changing it. So this is legacy code. When we're talking about testing legacy code, that means we have a jumble of code that's meshed up together, and we can write tests for it. But the problem is, because everything's meshed up together and can't be disconnected, that means we won't be really writing unit tests. We're going to write integration tests. By definition, these tests are slow. If we're going to call the code that calls the file system, or I don't know, a cloud interface, something like that, tests are going to be slow. We're going to talk about this later, but one of the things that make unit tests great is the ability to run them quickly. They require a big setup. Imagine that you have code that needs like a website application that has some kind of web configuration and accesses the database. So you have one scenario you want to test. So you need some kind of data set in the database and some kind of a configuration for the website. Now that's for one scenario. Imagine if you have 500 scenarios. We're talking about not only creating every type of setup that the code needs, but also cleaning up after ourselves, because we want all the tests to run all the time. So every test needs to be independent, and therefore we actually want to make sure that every test, when it runs, starts from a 0 point. Sometimes it may be impossible to run the system, especially in C++ systems that might not have all the dependencies it needs in order to run. And that means you can't really take the system from the production server, for example, and run it on your computer, or not run it in the same terms that have in your computer. So test might not run. And finally, we're talking about debugging, because big systems, usually what we do is we debug them. And these debug processes are slow. Imagine you're putting a breakpoint and getting to this breakpoint, and then understand you actually missed the right place to put the breakpoint in. So you go back, put a breakpoint, restart the session again, go there, do some kind of a fix, restart the session again, make sure that the fix actually worked. It didn't, so you need to do it again and again and again. And these are things that are actually take so much time that really is something of a detriment when we want to write tests. And basically, we're talking about a death spiral. This is something we've seen over and over again, which starts by the tests being too slow. When the tests are slow, let's say you have a suite of tests and they run for 15 minutes. At the beginning you don't really notice that, because the first test you write will take a second or so, but the more tests you write, you'll get to a big 10-15 suite, 10-15 minute suite run. So your tests are slow and you want to feel productive, so you do what all developers do. When you want to feel productive, you just you don't run your tests. You stop running the tests because you don't want to waste all these quarter hours on coffee. So instead of running a suite every, I don't know, 5 minutes, you'll run them every 5 hours. Now in these 5 hours you actually you felt productive, so you added code, maybe some tests, and you run them again. When you run it again, some test breaks. When they do, you need to debug, because you don't really remember which piece of code you actually added broke this test. So after a few times of this, you'll just stop writing tests, because you start to feel that you're actually working for the tests rather than them working for you. And then basically you're back at square one, when you actually wanted, you had a very good intentions of writing tests, but now you no longer either write or run them, which is kind of bad. You don't want to be in this place. By the way, the opposite of the death spiral is what happens when the tests do run quickly. We're talking about from milliseconds to 2 minutes, for example, for a very big suite. What happens then is something very interesting, because what will happen is that instead of trying to delay the runs, you'll start running them very frequently. So, and when you do this, the time slices between runs will grow shorter, and your ability to run, to add code, actually lowers. So you're going to add a bit of code, a bit of test, run everything, everything's working. Again, do this, everything's working. Add a bit of code, a bit of test breaks, a couple of undos, and you're back at the save point. You actually move much faster when you do have unit tests. So why does that happen? It happens because our code is tangled. We're full of dependencies, everything's written, everything together, and these dependencies appear in different ways. Either class A is passed a pointer to class B through the constructor or as an argument, or something available through a static method. And I might use new in my code to create a dependency, and it's mashed up together just right there. And I can think of other clever ways to actually do it again. So that's the problem. And it's kind of a dilemma, because now we want to write tests. But since our code is tangled together, I need to change my code. So it will be easier to test it decoupled from its dependencies. But if it's not like that originally, usually it isn't, and I don't have tests around, I don't really want to change my code to fit it for my tests which are not there yet. That's crazy. And let's face it, we're not crazy people. So, what do we do? So, a couple bit more smart people actually took this and thought about ways to actually go about this. And you probably heard this is about the term mocking. We call it isolation. It's a kind of mechanism or set of tools that let us test our code in different scenarios by faking dependencies. And depending on the framework you actually use, it needs to fit either the code as is or to some limit. I'll show you an example later on. So, first let's talk about Handrolled Mocks. These are mocks that you actually write yourself. So I'm going to switch to, I'm going to show my examples in Visual Studio 2010 in C++, and like this. Okay, so basically, let's see what we have here. So I have in my solution two projects, mailboxes, which is the code under test, it's a DLL, and mailbox tests, which is the test project. Obviously I'm showing this in Visual Studio, but C++ we can write all these things in every available compiler or stuff like that. So that would be our code under test, get count from provide. Now this method, this is a public method of mailbox, which gets as an argument a base message provider. It then looks at the message provider get count method. If it's 0, it returns no new messages. If not, it calls the create new message text method, which creates a new messages colon the number we actually passed it. Sorry, the get count. Now, what does base message provider look like? This is an abstract class, a pure virtual class. Doesn't have an implementation. So basically like an interface in Java, C#. And this is what we do when we actually don't have a concrete class. It lets us do something like this. So I can define a fake message provider. Let's just in my test project. I just want to show you my H file that derives from base message provider. Base message provider, remember, has the get count method, and I can define the get count, and I can define a set count method, which is only on our fake message provider. When I have this, I can write tests like this. So the scenario I'm going to test is, let me just hide this. I'm going to test get count from provider with item count is 0, and then I expect no new messages. So I can create my mailbox and my fake message provider. On the fake provider, I'll call set count 0 to return 0, and then pass its address onto the get count from provider. So this will make sure that when the get count method gets called on fake provider, it will return 0. On the other case, to test it, I can pass the same by the same scenario, but only this time I'm going to pass in 5. When I pass in 5 then and pass it in, I'm going to get back this type of string. This is what we call hand-rolled mocks or stubs or whatever. There are a lot of names. I mean, it's hand-rolled because you actually write them. Now, write them yourselves. Now, obviously, this is a very nice example, very clear, but this is an example. And the problem with hand-rolled mocks is that they started as naive and innocent, as we actually saw, but over time, and it doesn't take a lot of time to get there, they get complicated. Because what will happen is that we'll have a bigger interface. So for every getter method will have a setter method. And then, code under tested will probably have some kind of logic for that. Like we had here, mailbox, that we have ifs, right? So looking at what it will return. So we're going to have much more complex logic here, which will need to some kind of replicate in the mock object we just created, the fake message. And that's a very bad practice, because then we actually just have the ability, introduce the ability to enter bugs into our test codes, because mocking our fake message provider object, is now going to have logic of its own, so it might have bugs of its own. That's a very big problem, because we want to make sure that our tests are clear and bug-free. So when they fail, we actually need to be sure that it's something that we did in the production code, not the test code. This is actually what I started with a few years back when I started working with test-driven development. I actually wrote mock objects myself. Another thing about this will only work with virtual classes or virtual methods, because the way it works is we're actually overriding methods. So if you don't have a virtual method which you can't override, you're kind of stuck there. Okay, so let's switch back to my demo. So, like I told you, you can do this by hand, but you get tired very easily, and it gets complicated very quickly. So, a few more smart men thought about what we can do, and they came up with the idea of a mocking framework. And that is, basically, it will allow you to do two things. First, it's going to allow you to change behavior of the code without changing it, just like we did before, only the framework will supply the implementation of the specification of the method behavior. And it did another thing which I'm not going to show today, which adds to ability of asserting. Now we know that with every test framework we can assert on something. This something usually are return values from different methods, or some kind of fields that we can test on. The problem is that what happens when we don't have state to check on that something then actually changed, but our mailbox called some void method. So what do we do then? How do we make sure that something really happened? And regular test frameworks don't allow you to do this. Mocking frameworks to some extent can do this, as long as you're calling on a fake object. So I'm not going to talk about this a bit today. We will stick to changing behavior. So the same example as I showed you. Let me see. So this is what we did until now. So we created a provider, and it's called setCount on it. So I'm looking for something. So let's write a test how it looks like with isolator. So let's take excuse me for a minute. Need to find something. Okay, so let's take this method as an example. So I'm going to assume we have the same method, getCount from provider, and only this time, instead of creating my own fake provider, I'm going to use isolator++, which is a mocking framework for C and C++. So just copying this, and so the scenario is the same, but instead I'm going to use fake object. Now, basically, instead of these two lines, which I'm going to comment, what I'll do is create let's call it again a fake provider, and call isolators fake on the base message provider type. Yeah, I need to include isolator as well. Okay, so let's just delete these comments, and we'll need to include this as well. Okay, so provider. Now, what this does is create a fake object, and I need to tell it to return 5 when called. So I'm going to use a macro called when called, and fake provider getCount, return val 5. And then I'm passing in a pointer. So this is what a mocking framework does, exactly the same thing that I did before. I'm creating a fake object, this time of the original type. Then I'm setting behavior instead of just adding a method of my own. I'm just telling that when the method gets called, it will return 5. Very simple, and this is something you can do with mostly any mocking framework out there. Okay, what you can't do really is, like I said, there's a kind of a limitation that it works with only virtual methods. and you can't do something like this. So let's say I have a concrete message provider. Let's open the message provider.h file. This is a regular concrete message provider. This is not virtual. So let's go back to my mailbox. And my mailbox, just close this thing. And I have a get count from concrete provider, which takes a reference to of message provider. Same thing, same implementation, only this time you have a concrete class with a non-virtual method as opposed to what we had before. Obviously, this would be something that usually can't do with other frameworks, but you can do with Isolator. Let me just show you. Things like that. Again, it looks exactly the same. Breaking the type and then calling when called on it. So this actually works with Isolator. And this would be a good point to talk about different .NET mocking. Sorry, .NET? Where did this come from? Talking about C++ mocking framework. Let's fix that on the spot. This is not .NET, not you. Let's go back to our test, and yes, back we actually want to do. Yeah, this is a bug in a presentation. Should have written a test for that. Okay, so what kind of mocking frameworks do they have? As opposed to .NET, which really comes with a very small set of frameworks. C++, much like its test framework options, it's very fragmented. So you'll get different mocking frameworks like Google Mock or Hypermocks. I think these are the ones that are I most Gmock, I think. Sorry, CPP mock. That are basically community supported. The most, I think not the best one, because most of them have the same capabilities I told you until now. I think the most used one is Google Mocks. And they rely on the ability to fake virtual methods, to override virtual methods. Isolator++, for example, does not have this limitation. So you can fake concrete classes or change the behavior of static classes. And Isolator++ is the commercial one here. Aren't many commercial ones in the C++ area. So whatever you do when you're checking out mocking frameworks, check what suits you. Turns out it's not only about capabilities, it's also about APIs. We work a lot about working on our frameworks in terms of macros and APIs, so they'll be reasonably readable. But again, this is something that I suggest everyone evaluating the mocking frameworks for C++, try it for themselves, see what kind of capabilities and what kind of APIs are really something that you can live with them. Okay, this has been the mocking framework part of the presentation. I'm going to talk about what makes good unit tests, which is basically what you can do when you write tests to make them last longer and serve you better. Okay, so the first one is quick. Good unit tests are quick, they're fast. We're talking about running a suite of tests in a matter of seconds, like I said, maybe minutes. And again, the reason is unit tests are all about immediate feedback. You want to make sure that the code that you have under test works So you can move on to the next piece of code and next test and just edit and move forward. If it's not quick, you're going to get bogged down with a stairway to hell, the spiral. So one way to make unit tests quick is by using a mocking framework. Readable. I can talk about an hour for what readability means to me. When a test fails an hour from now, 2 days from now, or a year from now, first thing that you'll see is the name of the test. And the name of the test should be readable. And the way you know it's readable is by grabbing someone, hopefully in your team, by the ear and grabbing into your monitor and telling, can you read this? Do you understand what it does? And you saw a couple of examples of what I did in order to specify what's happening here. Let me switch to here. I'm using a pattern here that tells in the name that I'm testing the get count from provider method, and the middle part is what scenario specifically I'm testing, and for this specific scenario what kind of result am I expecting. And you can use your own pattern, but the way to know that something is really readable, again, is show it to somewhere. This is the same. This is the one thing that will show up on your screen when something, or your report when something breaks. So it gives you a lot of information, and so invest in it. Obviously, the rest of the test should be readable as well. And again, readable is for humans. It's by humans, not by reporting engines. And I always say this, the uglier your code is, the uglier your tests will be. But that's good, because if you don't have any tests for your code, uglier tests are better than nothing. And once you have tests around your code, then you can modify it, refactor it, and make it better. And again, the way to say if test is readable is only by the eye test of a teammate. Unit tests are focused. They test a slice of the applications. Test a slice which is small enough to help you get from. I always say that tests have two primary roles. The first one is notify you when something's broken. That's where the name came in. Second one is help you get as quickly as you can from found a bug to fix a bug. So if you're testing your code on a very small slice of code, that means that you're going to debug on, and this test failed. Because the test is focused, a few things will happen. You'll know exactly where in the code the problem is. It's going to be quick to debug because it doesn't raise the entire system. It requires a whole setup. It's focused on one piece of code, one piece of, let's call it, unit of work. It helps you focus on the problem, which is I have a bug. No, let's go fix it. So if you're testing too much, that means that your test is not focused. And you probably, if you get some kind of practice writing tests, you'll see that if your test is not focused, then you can't really name your test very well. So this will be a verse sign. Okay, tests should be robust. When we're talking about writing tests, especially with mocking frameworks, we're kind of decoupling our tests with our code, which makes sense. The more the test knows about the internal structural logic of the code, it becomes more fragile and less robust. And by this I mean that if something you change in the code under test, the test might break. And then you need to refix the test in order for it to work again. This kind of maintenance is something that many developers fear, and that having tests, we know that the code is going to change, therefore we're bound to have some extra work on the test themselves. But you will find that there are ways that, even by the tools, you'll find that some kind of practice will make your tests better in terms of robustness. For example, like when I showed you isolated plus, where's my code? You see the get count here, for example. This is my test, of course, and this is the code under test. Now, what happens if get count, I rename it to something else? Then this test will obviously break. But it won't break at runtime, it will break in compile time. And if I have a refactoring tool for C++, for Windows, you have Visual Assist, for example, you can refactor both cases in one click, and this basically makes your code more robust. The other thing you can see here that I'm telling when called only to change get count. What happens if message provider has all kind of methods? I don't specify them in the test because I don't care about them in the test. In some cases you might need to specify that. The more you specify the behavior in your test, first of all you might, like I said, might introduce some kind of bug in the test, not in production code. And second, if let's say a message provider had 5 methods, and I have when called for every method, and then I change the interface of my object, and then I'll need to refit the testing again in order for it to run. Now, writing tests is a skill. You'll get better at it over time. And I talked to guys that wrote tests, started writing tests 4 years ago, and I talked with them now, and they said that they're looking at the tests and they don't believe that they actually wrote these kind of tests because they would break all the time. They actually remember running to the tests and fixing them all the time 4 years ago. And the way they write tests now, that rarely happens. So this is a kind of a skill where you actually acknowledge, you learn to write tests, use the tools better, and write tests better. Okay, tests should be deterministic. I talked about this, I kind of refer to it with the bug in the fake object. We need to trust our tests, and that means every test, whenever it runs, alone or with others, or regardless at night or in daytime, or daylight saving time, remember the zoom, should give the same result. So if we actually, when I'm talking about deterministics, I'm talking about disconnected dependency from the computer clock, or from the file system, or from an internet connection. Your test shouldn't rely on this. If you do, then these are not good tests, and the best way to do is mock them using a mocking framework. Concentrate on testing your logic, not the clouds. Tests should be independent. Tests should, regardless of the order they run, if they run alone or in a group, in a kind of a category, if you're using CVP Unit or Google Test. Regardless of the order, they should again return the same value. Think about if your code changes some kind of static data. So your first test, let's see, like a singleton. So your first test might set up the singleton, the second one will not, because it's going to be set up already. And if you have this kind of dependency between tests, that's not good, because you might get different results on the same test on different runs. Very important for us to trust the tests. Finally, self-cleaning. Remember my example with the website, with the data and the configuration. And if I had one test, okay, I don't want to leave my database, let's say, dirty for the next run. So every test should be self-cleaning. That also means you can really self-cleaning means two things really. That it doesn't leave any side effects on the system, but also it should start from a clean slate. And you'll see this many times. The tests have most of the initialization, the setup and cleanup from the other things that went before them in the setup rather than in the clean area. That's a kind of a defensive programming thing, because you don't know what kind of crash will happen when the test runs. But there are patterns to help with that. So every test, again, because you don't know when and where it runs, will actually need to clean up after it's off. Okay. I want to take your takeaway from this will be a couple of things. First of all, when you start writing tests, hopefully you have already, but if you haven't, write quick and readable tests. This is basically the most important attributes of good tests, because these are the things that will let you keep on writing and running tests. If you're starting out probably on legacy code, you'll need a mocking framework. This is something that you probably don't want to wait with. Check out and evaluate different mocking frameworks, see what works for you. Obviously download Isolator, because it should be the first thing and probably the last thing that you evaluate. And see what works for you and for your code. And don't get discouraged if your tests turn out ugly. They do at the beginning. Just work at them so they won't. Before I open the floor for questions, let me just tell you can have a lot of unit testing information on the Typemock site and the Typemock blog and the Typemock Twitter account. I will also tweet out a lot of stuff. On the right you'll have my information, my site, which usually doesn't talk about unit testing. I do this more on the Typemock blog. I do talk about agile stuff a lot, and you have my email and my Twitter account. So if any of you have any questions, please write them in the question box now, and I'll try to answer them. Okay, one question, what about embedded software? Embedded software is usually written in C or assembler. I talked about C++ now, and Isolator++ means really C++. First of all, there's a very good book by James Groening about using tests activity with embedded software. A lot of tricks with function pointers. I can tell you that Isolator++ also helps mocking C also. So if you have C code, that will work as well. Okay, sometimes it's called multi-targeting. Sometimes you can, and this also goes with embedded, you can't run your tests on the platform. So let's see your production DLL. You want to test logic on it, but it can't really. You can't run the tests on embedded software, for example. So there's a process called multi-targeting. So you create one version of the production code ready for tests, and the second one is going to production your cycle, your automated cycle, will run the tests, and then you can actually do something. You can deploy it on the machine, the embedded module, or something else. If a class has more than one constructor, can we fake a particular constructor, or how does it actually work? Well, it depends on what you actually want to do. Faking, you'd usually want to fake out the entire object, not a fake constructor. The reason is that you're going to test the object through interaction. So you actually, if you fake out the constructor and basically run the real object implementation, might not work because things are initialized in the constructor. So what you usually do is fake the entire object and then set behaviors like the getCount thing on the methods that your code under test interacts with. But you actually can do wonderful things with Isolate++, like creating a live object, a real object, and then faking methods on it as well. So the question is not really which constructor do I fake. Usually you fake the entire object, and that means you don't call a constructor. It's not called. How does Isolate++ cope with mocking non-virtual functions? Very well. The technology that Isolate++ uses is that it allows you to change the behavior of any method. So, and that includes also different constructors and non-virtual methods and static methods, global methods, like C methods. So the main technology here allows us to change behavior of everything. So you can fake everything, like the things I mentioned. When I'm talking about faking different. By faking, you can have different options. So you can change behavior by returning a value, or you can return an object. Like if your method returns a pointer to something, so you can return that. Or if your method returns something by reference on an argument, you can actually fake that as well. Or call another method. Technically, how is it done? So there's a kind of injection going. We're not changing the production code. What I showed you, for example, is that the code under test was in a DLL. When the executable tester is compiled and linked, we actually we instrument it to have the ability to control this method. I actually faked the original class and injected it with kind of a is this really mocked method. So the jumpster that actually tests if there's some kind of specification. The technology is not overriding virtual methods like in other products, but injecting the code in the tester, not in the production code. So we're not actually changing the production code. Any more questions? Okay, one final question. Okay, two final. How does it work for dynamically loaded methods or classes? If you're talking about the product objects and methods that are in DLL and in static library, it works very well. Technology takes care of that as well. So if you're calling methods that are in a DLL, we actually intercept these methods as well, so we can set behavior as well, and it's also works with static behavior, and also static meaning either a static library or inside and the executable itself. Okay, what platforms? I showed you Isolate++ on Windows, which is the main platform. It works with Visual Studio 2005, 8, and 10. We also have on the site, you'll see it, Isolator++ for Linux. We have different distributions of Linux that we support. Only this version is less stable than the one we have on Windows, and it will be like that for a while. Hopefully by next year we can upgrade it to work like its big brother. But currently, in terms of roadmap, we're actually putting more development resources into the Windows. Other platforms that were not supported today, I'm actually researching them. Again, for embedded software, we kind of the current thinking is that we're going to support this for now at least like a multi-target process. You can compile and test on one thing, then produce the code for real-time on real-time OSs. But we'll see how it goes. We see, because there's so much work that being done in C today on many different platforms. We will look at that all the time to see where we're going to actually, what we're going to do next. So hang on and keep listening, and we'll have news. Okay, last chance for a question before I close this down. Okay, this time no questions. So I want to thank everyone who came here today. And like I said, if you have any questions, you have all the places to go when you want to get most of the answers. Download Isolator++ and try it. And hopefully it will work for you. And we really want to hear your feedback. So thank you very much. Keep listening to listening on the blog, and might be other webinars on this kind of thing. Thank you very much, and bye-bye.